Okay, next up in our tour of the area of shapes, we're going to look at the area of a kite and the area of a rhombus. Exactly the same formula, at least. If you imagine what they look like, they're very similar looking shapes. Okay, if I try and do this, a kite, often just remembered by the shape of a kite that we all remember from flying. Okay, that's a kite. And then a rhombus is basically just a diamond. Okay, so just a more even version of that. Not very good attempts there, but you get the idea, okay? So similar kind of idea, but the formula is exactly the same. And there's a couple of ways of doing it. You can do it like a composite shape, and you can actually split it up, okay? You can split it up into 2 triangles, like so, and like so. You can split it up into 4 triangles, like so, and like so. Or what a lot of people like to do is actually draw a rectangle all the way around, okay? And note that similar to when we're doing a triangle, the actual area of the kite or the rhombus inside will be half that of the surrounding rectangle, okay? And that's basically where the formula comes in. So the area of a kite or a rhombus is half, and what we call it is times the diagonal 1 times by the diagonal 2. And what we mean by diagonal 1 and diagonal 2 is the fact that it's this distance basically straight across the shape. So that's a diagonal 1 and that's a diagonal 2. It doesn't matter which one's which, but it's basically just the diagonals multiplied together. If you can see how these relate to the outer rectangle, then that's why we need the diagonals, because without those rectangles actually drawn in, there's no relevant dimension within the kite or the rhombus. So it's those 2 dimensions that we need, that are there in red, okay, the 2 diagonals, and when we multiply them together and we half it, we'll find the area of the full thing. You'd still find that same shape, same formula, sorry, if you used the individual triangles, okay, because at the end of the day, the individual triangles, what we need is we need the dimensions up and down in terms of the triangles, okay, so I'd need both of those dimensions, and I'd half at the end. It's just a bit more complicated doing it that way, so we're much better off dealing with this version and going from here, okay. So if I give you a couple of examples, I'm going to try and do this with, ooh, there we go. Oh, no, you stay there. Okay, so just flip this on its side slightly. Nope. And here we have a nice even kite. Look at that. Right. What we'd be given is we'd be given these dimensions in some form or another. Okay. So I'll put a dimension in there and a dimension in there. It all starts getting a little bit condensed and a little bit close, but we'll deal with that. Let's say this is 8 centimeters and let's say this is 12 centimeters. Okay. So if I'm going to find the area of that, I need my formula. And again, similar to when we're dealing with rectangles and triangles, we've just got to identify the fact that it is a different shape, in which case the formula to find the area is, again, different. Okay? So for this one, kite or rhombus, something like this, it's this formula that we need. Okay? Half times by the diagonals multiplied together. Okay? So it's going to be a half times by 8 times by 12. Okay, we could have written 12 times by 8, doesn't matter. As long as we're multiplying, it doesn't matter which order we do it in. So it doesn't matter which one of the diagonals comes first. Okay, and then from here, okay, it's just a case of how we tackle this. We can do a half times by 8. A half times by 8 is just 4. And then we still need to multiply by the 12. That gives us 48. Okay, I could have done this slightly different. And I'll write it alongside it. I could have done 8 times by 12. So then I'm left with a half times by what 8 times 12 is. 8 times by 12 is 96, and a half of that is 48. I could have, if I wanted to, I could have done a half of 12. Okay, half of 12 is 6, and then I just need to do 6 times by 8. 6 times by 8 is still 48. So when you have a list of multiplications like this, okay, it doesn't matter which order you times them in. You pick whichever one you're going to find easiest. A lot of people think it's probably easiest to take the fractional bit, the bit that's probably going to be the most awkward, and multiply it by the biggest number that you've got there. Half of 12 is 6, and then it only leaves us with a nice straightforward standard times table multiplication left, 6 times by 8. Okay, whichever way you choose to do it, you should still get the same answer, and therein lies a way that you can check that you've got the right answer, okay? But either way, the answer, actually, at the end of all this, is to do with units. It's not just 48. So because the units in the start of the question were centimeters, then our area will be centimeters squared, okay? Right, another example. Let's go. Oh, you stay there. Diamond. okay? Or a rhombus. It's only, a lot of people use diamond when they're in primary school, but this is a rhombus. It might be, it might look like a square to you, it might look like a parallelogram to you, but the point is it will be these dimensions that you're given. So you'd be given something along the lines of, let's say, this length here, and this length here, okay? The point is they're not the diagonals, but from them, because we know it's a rhombus, we can work out the diagonals. So let's say this is 9 meters, and let's say this is 6 meters, okay? So we've still got the shape that requires this formula, okay? So it's not half base times height, it's not length times breadth, it's a rhombus, so it's half times by diagonal 1 times by diagonal 2. What we've got to do here, we've got to look at these dimensions and realize that they're not the full diagonal. What I want is I want that length there and I want that length there, okay? But my knowledge of shapes, okay, from back in primary school and stuff, I know that this 6 meters basically accounts for half of that diagonal. And likewise with the 9 meters, okay? So if I'm going to use this formula, if I want the diagonals, I need to double these two numbers, okay, and then pop them into the formula. So diagonal 1, let's say, is the 9 times by 2, which gives me 18, and then the other diagonal is the 6 times by 2, which is 12, okay? I know obviously we're going to half in at the end, but let's just do this properly. Let's just take our time with this, okay? So it's half times by diagonal 1 times by diagonal 2. Right, now we've got much bigger numbers. It's much a little bit more complicated to deal with, okay? So again, we have to think about this carefully. If I was going to do 18 times by 12, first of all, it's long multiplication, that might be a bit more complicated. So I might want to avoid that. So perhaps focus on what I said before. Take the fractional part and times it by the biggest number, okay? Right, half times by 18 is 9. So I've done that bit, I still need to multiply by the 12. This might require a sum, okay? And if it does, then just do it to one side, okay? 9 times by 12, 9 times by 2 is 18, carry the 1, 9 times by 1 is 9, plus the 1 is 10, 108, okay? But again, it's not just 108, because we need a unit, it will be 108, and this time meters squared because it's area, okay? Right, had I chosen that to do that differently, I could have done half of 12 is 6, and then I still need to times by 18, okay? 6 times by 18 is 108, or I could have done 18 times by 12, 18 times by 12 is 216, and then half of that is 108. Okay, so you could have picked one of those methods, one of those routes, still get you the same answer. It's just a case of what you find easiest in the first stage. But as long as you have a situation like this, where you have 3 things or more multiplied together, you can pick which order you do it in. Okay, half times by d1 times by d2 is the same as a half times by d2 times by d1. So it doesn't matter which order we do it in. Okay, whichever you find easiest to get you to the answer that is required, 108 meters squared.